Myself, M. Dinesh Kumar, Assistant Professor, Department of Mechanical Engineering, Konganadu College of Engineering and Technology, Trichy. Engineering, Thermodynamics, Unit 4, Properties of Pure Substance. These are the syllabus. Thermodynamic properties in solid, liquid, vapor phase, phase rule, PV, PT, TV, TS, HS diagram, PVT surfaces, steam formation and its thermodynamic properties, calculation of work done and heat transfer in non-flow and flow processes using steam table and a Mollier chart. Pure substance. Pure substance is a substance of constant chemical composition throughout its modes. A pure substance does not have to be a single chemical element. A mixture of various chemical elements is also called as pure substance, as long as the mixture is homogeneous composition. Homogeneous in chemical aggregation, invariable in chemical aggregation. Example, H2O, water. Air acts as a pure substance. Formation of steam and its thermodynamic properties. This is plotted in y-axis temperature, in x-axis heat added. Minus 10 degrees Celsius, so point A is a solid state, point B is a solid warming process, A to B. C, D, E are some important points are noted here. Here the steam formation from ice to steam, it will be declared in the diagram. Minus 10 degrees Celsius ice is added the heat, it starts to melt up to 0 degrees Celsius. The point B, 0 degrees Celsius ice is there. When further you have to add the heat, it will be start melting. So B to C is the stage of melting. In this case of B to C, heat addition is latent heat of fusion. So 0 degrees Celsius ice into 0 degrees Celsius water, solid phase to liquid phase. Phase transformation is done at 0 degree Celsius. Next, 0 degree Celsius water is further heated at 1 atmospheric condition. So it will be heated, it increases the temperature up to 100 degrees Celsius. So 100 degrees Celsius, up to 100 degrees Celsius heat added, that heat we call it as sensible heat. Then 100 degrees Celsius of liquid start boiling. So in this stage there is no temperature rise, so only 100 degrees Celsius is there. Point D to E, liquid plus vapor phase is there. 100 degrees Celsius liquid is converted into 100 degrees Celsius vapor, that is dry steam. So in between that liquid plus vapor, the steam we call it as wet steam. So this point D to E, the amount of heat added we calculated as a latent heat of vaporization. After that point E is a dry steam is further heated, that steam we call it as superheated steam. In that figure, say 200 degrees Celsius. 200 degrees Celsius is a superheated state. So from the point E to up to 200 degrees Celsius heat we call it as heat of superheating. This is a vapor stage. This is the formation of steam from ice to vapor. Ice is melting, this is a melting stage. Then liquid will be temperature 100% increases, then this portion is a vaporization, then further heating is done, so superheating. Liquid plus vapor, wet steam. Point E is a dry steam, then superheated steam. We may be 500 degrees Celsius, 600 degrees Celsius, up to the capacity of the boiler we can increase the temperature of the steam. So that is three kinds of steam. First one, wet steam, dry steam and superheated steam. You note that whenever the phase changes from solid to liquid, the temperature is constant. Here also from D to E is a vaporization stage, that is liquid phase is converted into the vapor phase. At the time also the temperature remains constant. During the phase transformation, temperature is constant. You can understand from this diagram. Next, phase rule. The number of independent variables associated with the multi-component multi-phase system is given by the phase rule. The Gibbs phase rule is expressed as a equation n equal to c minus theta plus 2, where n equal to number of independent variable, c is a number of components, theta is number of phases present in the equilibrium. Here we discuss about the pressure temperature diagram, that is phase diagram of pure substance. Pressure in vertical axis and temperature horizontal axis. The three variables, three portions, solid, liquid and vapor phases. The three phases are connected at a single point. That point we call it as triple point. Here you see the sublimation curve. This curve separates the solid phase to vapor phase, which means solid is directly converted into vapor without forming the liquid phase. So this is the process of sublimation. Next one, PV diagram of pure substance. The pressure and volume diagram is already the points are discussed. This line is a saturated liquid line. This point is a critical point. After that, this line is saturated vapor line. Before that saturated vapor line, the liquid plus vapor phases are present. That means wet steam. After that, the saturated vapor line, we got a superheated vapor region, that is superheated steam. This is HS diagram or Mollier chart. Enthalpy entropy diagram. This is also called as Mollier chart. We know that this line is a saturated vapor line, then this is a saturated water line, this is saturated vapor line. This line is a constant pressure line, this line is a constant temperature line. For example, at the point of the saturated line, they take it as a horizontal scale, is a dry enthalpy value, we can note it down. Then in a vertical scale, dry entropy, we can take it from this diagram directly. Mollier chart is a graphical representation of the values which will be recorded in the steam table. It will be converted as a graphical representation in this Mollier chart. We can easily identify the properties of steam at various stages and various pressure and temperatures also. This is the table properties for formulas for various kinds of steam. For example, enthalpy is a property of steam. If it is steam is wet steam, H wet equal to Hf plus X into Hfg. This formula we can use. If it is a dry steam, Hg equal to Hf plus Hfg. If it is superheated steam, the enthalpy of superheated steam equal to Hg plus Cp into T soup minus T saturation. Cp is a specific heat capacity of steam. This is superheated temperature. This is saturated temperature. Hf is a fluid enthalpy. Fg is a liquid plus vapor phase enthalpy value, which is mentioned in the steam table for the various pressure and temperatures. We can take it from the steam table and we can use this formula to identify the enthalpy. Similarly, the specific volume formula, V wet equal to Vf plus X into Vfg, V dry equal to Vg, V soup equal to Vg into T soup divided by T saturation. In same way, the similar formulas are, we can recall it while solving the problems. Take a sample problem to understand these kinds of identifying the condition of steam. Let's see the sample problem. Determine the condition of steam, whether it is dry, wet or superheated for the following cases by using steam table only. Steam has a pressure of 10 bar and specific volume 0.22 meter cube per kilogram. In second case, a steam has a pressure of 15 bar and a temperature to 25 degrees Celsius. In third case, steam has a temperature of 200 degrees Celsius and enthalpy 2790.9 kilojoules per kilogram. Fourth case, temperature 120 degrees Celsius and entropy 7 kilojoules per kilogram Kelvin. As per the given data, we can write the pressure 10 bar, volume 0.22 meter cube per kilogram, and second case pressure 15 bar, temperature 225 degrees Celsius. Third case temperature 200 degrees Celsius and enthalpy 2990.9 kilojoules per kilogram. Fourth case temperature 120 degrees Celsius and entropy 7 kilojoules per kilogram Kelvin. We have to identify the condition of steam. From steam table we can write the values for saturated volume. Vg value from 10 bar pressure first case, Vg equal to 0.1943 meter cube per kilogram. This is the steam table. It's a pressure table. 10 bar pressure, the saturated temperature 179.9 and Vf value 0.001127, Vg value 0.19430, Hf 762.6, Hfg 2013.6, Hg 2276.2, Sf 2.138, Sfg 4.445, Sg 6.583. So which is taken from the steam table, and we can further proceed the values. From the steam table we can take it 10 bar pressure, Vg as it's shown earlier 0.1943 meter cube per kilogram. We have to compare with the given value 0.22 is greater than that of 0.1943. So the given condition of steam is superheated. Then second case, 15 bar, temperature 220 degrees Celsius, 225 degrees Celsius. Same way we have to go to the steam table and identify the temperature, saturated temperature for 15 degrees Celsius 198.3. Then we have to compare given temperature 225 which is greater than the saturated temperature. So the second case is also superheated steam. We go for the third case, 200 degrees Celsius enthalpy value is mentioned. From the steam table, temperature table, 200 degrees Celsius Hg value here they are almost same, 2970.9 kilojoules per kilogram. So which is equal to the Hg value. So the condition of steam is dry and saturated. For the fourth case, 120 degrees Celsius saturated entropy 7 kilojoules per kilogram. From steam table we have to identify 120 degrees Celsius Sg value 7.129 kilojoules per kilogram Kelvin. While comparing with this given entropy which is less than the Sg value, so the condition of steam is wet. By this way we can identify all the properties of steam by using steam table as well as the Mollier chart. Thank you.